In this video, I'm going to teach you how to calculate empirical formulas given percents. And there's a very practical application to this idea of empirical formulas. So this is how we use certain types of lab equipment in order to determine what is the chemical makeup of an unknown substance. So if we think about, like, for example, a crime scene. Say you were to find some white powder at a crime scene and you wanted to determine whether or not that powder was, sugar or salt, or it could be baking soda, or it could be cocaine, and you can't really tell based on its visible appearance, and so we can use some methods in order to figure out the percent composition and therefore use the percent composition to find the empirical formula. So a couple of different ways in which we can do this is, one is by something called gas chromatography. And basically, gas chromatography, you take a substance and based on its physical properties, it separates the substance out and tells you the relative amounts of each thing. You get this like readout that tells you have this much of this and this much of this, and it can give you the percents of each individual element that are present in that sample. Another way you can do it is by mass spectrometry. And I give you this, don't worry about all this physics calculations, but I just wanted to show this to you for those who plan on taking EP Physics or have taken it before. But essentially, the a mass spec, essentially what you do is you ionize the whatever it is that you have, the sample, and then you shoot it up through a magnetic field, and basically what that makes it does as it flies through the magnetic fields, it arcs in a circle and hits this plate right here. And based on how big it is, determines where it's going to hit on the plate. So we basically separate out a substance based on its mass. So these are just two different ways in which we can get percent composition of an unknown substance. So I just wanted to mention those to you. But let's go ahead now and talk about how we actually calculate an empirical formula from the percent composition. So it's very similar to what we learned in the last video, but we just have one extra step. So we're given percents, so what we're going to do in order to make our molar conversion is we're going to assume that we have 100 grams of the sample. So if you say some sample 75.1% carbon, then we assume we have 100 grams, so we just turn the percent straight into a gram, and you say that there are 75.1 grams of carbon. Then we just follow our steps like we did before. We convert from grams to moles, and then we find the lowest whole number ratio by dividing by the smallest number of moles. So let me just give you an example. Let's say we have a compound that's composed of 38.67% carbon, 16.22% hydrogen, and 45.11% nitrogen. So again, let's assume that we have 100 grams of the sample. That means we would have 38.67 grams of carbon, and then I'm going to convert that from grams to moles. So converting grams of carbon to moles gives me 3.22 moles of carbon. Then I take my 16.22% of hydrogen and I go from grams of hydrogen to moles of hydrogen. And then my 45.11% becomes a gram, and 1 mole is 14.0 grams of nitrogen. So I end up with 3.22 moles. So the lowest number is 3.22 moles, so I'm going to divide each of these by 3.22 to get the lowest whole number ratio. So 3.22 divided by 3.22 is 1. And then 16.22 divided by 3.22 is 5. So essentially what I get is 1 carbon for every 5 hydrogens for every 1 nitrogen. So the formula would be the empirical formula would be CH5N. Okay, so you can practice these now using percent, so just remember that one extra step where we turn the percent into the gram and then follow the same process like we did before.